I've been a software developer trying to produce sustainable software. More recently, I've been working with application scientists at the Marine Biological Laboratory and the Woods Hole Oceanographic Institute, trying to figure out what software can an application end user use. And now I'm with the funding agency. So one of the things I noticed as I was kind of going through my slides is when I refer to our or myself or the group that I'm part of, I'm shifting. So I apologize for that because I've really seen this from a number of different points of view. I'll start off with a definition of sustainability that I'll use, but this is something we really need to discuss over the course of the day. Sustainability, if you look it up in a dictionary, it's the ability to maintain certain processes or state. In a software environment, what I'm going to refer to as reuse is creating software that can be used broadly. Many application domains over a long period of time by people who didn't create it in the first place, and looking at the funding models to encourage this long-term support. The vision I'd like to set out for you is one where software is seen as infrastructure. The same as a telescope, a collider, a shake table. It's a line item in a directorate budget within NSF. We've got 10-year plans for the funding of software as infrastructure. We factor in maintenance and replacement. Software is eligible for large-scale infrastructure funding, like the Major Research Instrumentation Program and the upcoming Academic Research Infrastructure Program. Software should be a first-class citizen. Software is around even longer than a lot of the hardware. Computer hardware, we're refreshing every 3 years. I'm working with oceanographers that are building on codes that have been around more than 20 years. So we really would like to have software viewed as a first-class citizen and as infrastructure within NSF. However, if we go down that path, we need to change not only how the funders are viewing software, but how the creators of the software are viewing it. If software is infrastructure, like a telescope, that means we need to have reliable, robust, reproducible, production quality infrastructure. We need to have additional reporting requirements. A telescope has to report its uptime, the usage statistics, safety and security reporting. How many software projects are doing that today? A few, yes, but many are not. We need to have a formal approach to planning. This isn't software being built for you and your 3 graduate students. We're looking at software that has to have a production approach to scheduling estimation, requirements, development plans, risk assessment. We're really looking at a professional engineering background for these teams. I wouldn't want to be sitting in an office in a building that had been built by a bunch of third-year grad students. Why should we be pinning our software as infrastructure on that team? This is a change in culture, fundamentally changing how both funding agencies, software developers, and end application users look at software. This is not more money. I had someone come up to me at the end of the reception yesterday and say, you know, I'm hearing a lot of people saying if NSF would just write a bigger check, we would be done. There's our sustainability plan, just get a bigger check. And especially with the stimulus money, people are saying, oh, you can write a lot bigger check, right? You've got half again in your budget. More money is not the solution. Spending the money we have wiser is the solution. Looking at how do we do longer term planning and how do we build this as infrastructure. So if we take as the premise software as infrastructure, is this the right premise? I'd argue it is. Maybe we can discuss it some more. How do we realize this? How do we look at these problems? These are the hard questions I'm hoping this workshop will begin to address. One way forward, which I'm going to spend the next 20 minutes or so discussing, put my watch up here to make sure I keep to time, is what changes can people developing software make in order to convince the rest of the community, including the funding agencies, that software is mature enough, cyber infrastructure software today is mature enough to be viewed as infrastructure, so some of these other cultural changes can trickle out. So what I'm going to do is I'm going to walk through one of the first programs that within OCI, before OCI it was actually OCI, called the NSF Middleware Initiative, that looked at sustainability funding for software, and specifically talking about a project called MyProxy as an example of a way that this might succeed. I'll talk about some of the lessons learned in the follow-on program called SDCI. Then I'll talk about how do we encourage sustainable software. What do we need to do in education? What do we need to do in changing community attitudes? And then I'll pose some questions that I hope we'll discuss. So NMI was established in 2001. A number of you were PIs in that. It was really looking at how do we share these resources, share this software, work with end application users. MyProxy was one of the projects that was funded through this. Vaughn Welsh is here. I've also spoken with Jim Basney about this project. They've supplied me with this information directly. It started in 2000, working closely with end users, specifically funded by NASA to do changes for online credential repositories for grid portals. They applied with this software base and these initial users to the NMI program and were funded to test and harden, document, and come up with release strategies. Part of that NMI program funding also helped them become part of a release with the Globus Toolkit and then the NMI Grid Center. It did fund a little bit of additional features, specifically in support of NSF communities, but the bulk of it was for this hardening and sustainability. Because this was a production piece of software, it was picked up quite broadly. It's currently funded through programs like TerraGrid, which support the use of that software for TerraGrid end users. It's gotten additional contributions from the European Data Grid, University of Virginia, LBL, and others. It is an open source project, but more than that, it's an open contribution project. It puts the code out there not just so that you can view it and change it for yourself, but so that you can contribute back to it. It's used today by a large number of projects, and it's used heavily. It's not just in their software stack. The worldwide LCG project is doing almost 250,000 requests every day to a MyProxy server. So this is really a robust, reliable piece of software that grew up in this space. I sat down with Vaughn, or I think we electronically sat down, and talked about what worked, what really made this project a success. And these were some of the things he pulled out. They had a clear user need from the start. They started with end users who had an identified need, started there, made sure that was solid, and then grew organically. They didn't start off with, you know, here's a problem I'd like to solve, maybe someone else is interested, or I'm kind of hearing that this is an important issue, let's see where it'll go. Once they had that initial prototype, they made sure it was robust, gained and maintained user confidence. You don't get a second chance to make a first impression. So if you do any reading of production software management, this is one of the fundamentals that they tell you. When you do a release, make sure the first 2 seconds of a user's experience, that's 98% of the time that you have to influence an end user. If within that first less than a minute, a user isn't happy with what they see, they're not coming back. I was recently part of a large infrastructure project in the biological space, and they say, oh, look, we've had 10,000 users in the last week. What they didn't report was that 80% of them stayed on the site less than 5 seconds. When MyProxy started off and they built and did releases, they maintained stability. Every release was backwards compatible, again, in order to have this user confidence. When they did their architecture, it was simple software design, it was open source and coherent. This allowed them to not only coordinate new features and contributions, but it also was set up in such a way that users could look at it and say, right, it will be easier for me to add on to this piece of software instead of building it myself. We've all seen the not built here syndrome. Well, you know, it'll be easier for me to just do this from scratch. They did things in such a way that that was strongly discouraged. They also had long-term support from NCSA in terms of bridging funding should they run out. Some additional lessons that came out of this, in my view, they had strong end-user involvement. Understanding user needs is really, really hard. The 3 years I spent in the UK was mostly working with end users. I can't count the number of tomatoes I've had thrown at me virtually, or the number of beers I've bought for people saying, I'm really sorry you've had a hard time of this. But working with end user communities is fundamental in order to have sustainable software, in order to have that buy-in, in order to understand where you should be going. Saying no, this is something that none of us really does very well. We wouldn't be here if we did. However, overselling and overhyping software is a consistent problem we've seen in this community. Cyber infrastructure, we've all seen the hype curves. Cyber infrastructure has been oversold time and time again. Software in this space has been oversold. We need to be more careful of that. We need to be able to deliver what we say. When I got into more professional production management of software, I found a number of management books I really liked. One of them is called Get Real by the 37 Signals Group. These are the guys that built Ruby on Rails. And they basically have a number of tenets. It's very hardcore. They basically say, you know, your first answer is no, your second answer is no, your third answer is no, your fourth answer is, well, maybe we'll think about it, but it's really no. They have this wonderful quote, it's better to make half a product than a half-assed product. And I love that. I would much rather see something very simple that works well than something that promises the world. The other reason for going down that path is if you add on extra features, if you let the project grow, that's additional support burden, which you've got to consider. I'm not saying don't add features that users say they need. I'm saying be careful about it. Also, the scope of the software. This is something that MyProxy did especially well. They chose a problem that was well-defined and did it well. They didn't try to solve everything. If you think about it, it's solving a single problem. We've seen this in the Unix space especially, where people come up with a simple tool that works well, and then you can add on to. The harder question that we have to ask in this space is, how do we choose what to support? This really isn't the topic of this workshop, but I wanted to throw it out there as something to think about. If we think about software as infrastructure, if you think about building a telescope, we don't build 7 or 8 telescopes that all do roughly the same thing. We might build 2. How will we make those choices? How will we decide to have a simple architecture across cyber infrastructure that can coordinate? I don't even know how to evaluate a real core of cyber infrastructure, but this is something we need to do and something we need to do soon. We also need to come up with exit strategies for tools that have lived past their lifetime. We can't continue supporting everything, so how do we think about that and the transitions that will have to take place? The follow-on to the NMI program was the Software Development for Cyber Infrastructure program. This was in 2007. This was a really great program. It funded proposals in 3 different areas, HPC, data, and middleware. And there were 2 types of proposals. There were new development, which had to show a need within the community, a documented need for a piece of software to support a large set of end users. Or it funded improvement and support. And again, the software had to have a proven track record and end users were asking for it. A number of you here in the audience have been funded through this, which is great. When these proposals were submitted, this is something we're looking at as going forward. We might be able to do this in 2010, is my hope. All of these had to be open source. You had to use the NMI build and test facility, and written into the solicitation was you have to do a demonstration, either at the 12 or 18-month mark. So all of you who have had these awards for the last 2 years, you should be getting in touch with your relevant program officer and saying, hey, I'd like to sit down with you and do a demonstration. I'd like to talk to you about the end users working with me. Okay, so I've talked about encouraging support of sustainable software. Let's talk about what can happen in the broader community. One of the things we'd like to see is people really teaching software engineering to produce sustainable software. I went online to a random university and pulled down the itinerary for their software engineering course. Nice software engineering course, you know, each of these was roughly a 1-hour lecture, covering kind of the basics. Everyone in the class was also doing an individual project. They met and talked about that several times over the course of the semester. However, that basic software engineering course misses the boat in producing production software. They didn't talk about working in a team. Every project we're looking at in a sustainable environment involves teams, which involves everything from communication to version control. I'm still shocked at the number of groups that don't have a basic CVS or SVN repository set up for their software. $1-million projects have everything on a laptop that gets backed up once in a while. That's an individual programmer. This is not how we have sustainable software. We need to talk about working with end users. We need to talk about production operations. Deployment, performance criteria that you have to meet with your software. Interoperability, either between your software in previous versions or your software and the other software in the expected software stack. How do you work to deadline? These are the things we need to be teaching in our software engineering courses. Care and feeding of production software, version control. Everybody's heard these things, but we don't teach them. We don't teach our students and our community to build sustainable software, so how can we move forward? Some courses do. So the first place I went to look at software engineering programs was UCSD. It's where I did my graduate work. And they actually had a really nice course walking through agile techniques. They worked in a team with a set of end users who played that role throughout the quarter. They looked at version control and release cycles, how to weigh in when to add features versus hardening a piece of code, which is, I think, a step in the right direction. Problem here is how many computational scientists take this course? I had a note on an earlier slide. I'm defining software quite broadly. I'm not just talking about things like Globus. I'm talking about libraries. I'm talking about mathematical applications. One of the things that Ed Seidel is really pushing in the computational space is software provenance. If we can't reproduce a software run, this isn't science. Basic science tenet, you need to have a reproducible experiment to have a scientific result. Right now, because we don't do version tracking, metadata tracking, environment tracking for most pieces of software, we don't have reproducible results. So how do we change this? What can NSF do? NSF needs to educate our community. I had a phone call last week with a PI who was rather dismayed at a recent award. He had submitted a proposal to a program. The review panel for the program had been told this program supports code hardening, broadening of uptake. This is as close as we get to a sustainability program today. The software in the project that was proposed has a large set of end users, a very broad community uptake, especially within the NSF directorates. The proposal as submitted was primarily support funding for NSF users with a small amount of additional feature development. However, the review panel came back and said, we think you should fund the new features. The rest of this, it's not really relevant here. This is a failing of our community. This is a failing of our community to acknowledge that sustainable software needs to be supported. We've all heard this. I mean, I have had my own reviewer comments of people saying, well, why are you hiring a developer at Argonne? You know, for that salary, you could have 4 graduate students working on this. So, well, do you really want graduate students working on your security code here or your monitoring code? Let's think about that. Again, for educating the community, one of the things we do in OCI is we do a lot of work with different directorates. I spend a lot of time working with the biologists, the geologists, the engineers. I've inherited a portfolio that has about 120 open projects. I've been told that's fairly small for NSF. The best way for me to learn about these that I don't already know is the annual reports. These are meant to be a way for someone building a piece of software, for example, to update me, the program manager, on its status, to tell me what it looks like, to give me some indication of, can I use this somewhere else? When I go and talk to the iPlant guys, can I recommend a workflow system? Can I recommend a directory structure to them? If you look at the annual reports, they're actually quite challenging. Within NSF, you get a pre-filled out template. It's actually pre-filled in with the previous year's response. We seem to have a small problem with the system that often the previous year's report gets sent accidentally for this year, which is a bit challenging at times. What I'd really love to hear from people doing these annual reports is, tell me about your user base and the involvement. For these pragmatic programs, give me a pointer to a web page that I can point someone else to, that isn't just a list of files where you've put results or traces, that actually is useful to an outsider. Tell me about your open source license. Tell me about how someone else can come along and use this. That's part of the education we have to change. So that's very different than what you would put into a scientific paper or a program out of size. If you were reporting on a theoretical scheduling result, I'll give you my paper references. I'll tell you that I've improved this to, O of n plus p squared. That's not useful when you're looking at software reuse. We don't have the right metrics yet. One of the things we're doing within OCI is we've created a series of task forces. This is one way for us to get more community involvement in implementing the initial vision that was set out and looking at how that vision is going to change going forward. These task forces have been set up to run for roughly 12 to 18 months. They're co-organized by an NSF program director and a member of our advisory committee. The membership involves advisory committee people, community people, other agencies, and we have involvement from a number of NSF directorates in them as well. What these task forces are going to do is set up a series of workshops that will then result in recommendations that will then get fed into programs. We've identified 6 areas to have task forces in: software, campus bridging, educational workforce development, high-performance computing, data visualization, and grand challenge communities and virtual organizations. I'll tell you a little bit more about those first 2. The software task force is being overseen by Abani Patra. All of these, of course, overlap and interact. He's looking primarily at tools, compilers, application frameworks, and debuggers, and where they should be moving forward to. How do we have a comprehensive CI environment? How do we have community frameworks? And how do we deal with sustainability? I'm working primarily with the campus bridging work right now. This is everything from networks to understanding software stacks, looking at all aspects of how do I get my campus infrastructure to work better with regional, state, and national infrastructure. Sustainability is also a primary factor here. I'm just going to walk over those. There's a lot we can learn from other institutions and other funding agencies. NASA has this really great reuse readiness levels that Peter Fox was talking to me about last week, where they assess the maturity of software projects for potential reuse. This gradient is also what they've been using in the Ocean Observing Project within NSF to try to figure out what software makes sense for that in terms of reuse. Can we take something like this and adapt this for use within NSF and OCI? There's a lot of European projects. Neil Chu Hong is going to talk about OMI tomorrow. Stephen Newhouse is the former director of OMI as well, so we've got both of them here in the audience to pester when questions come up. OMI was set up to provide hardening and sustainable funding for the UK e-science program. E-science is roughly equivalent to Cyberinfrastructure. It worked well in terms of creating an engineering integration by the project office. They had a way to choose what software to support, to work with the people who were building the software in order to try to harden it and broaden the use. However, the effort far exceeded the results or the expectations, and also it was noted that early intervention was needed for better results. We're back to this training people to write sustainable software so that when you start off writing a piece of software, you take into account the longer term. A lot of groups are looking at policies to preserve data artifacts. This has been something that the European Commission was working on most of the time I was in the UK 4 or 5 years ago. This is something NSF is actively trying to determine what kind of data artifact policy should we have across the foundation. Right now it varies directorate by directorate. Some require data to be publicly accessible within time frame. Others do require putting data into a national archive, etc. We've all heard these issues. Do we need to look at preservation of software artifacts? How can we make them publicly accessible, to have testing results accessible, to have required demonstration, required end-user vouching? What would a software policy of the same nature as a data policy look like? This would involve metrics for use, metrics for how the software was produced, not what the results of it were, but how good was the testing and infrastructure? How good were the releases? How does it do for backwards compatibility? How do we capture those requirements of the software process? How do we encourage this in an academic environment? How do we reward sustainable software? And of course, if we're successful in having sustainable software and having reuse across a broad set of projects, how do we deal with this extremely complicated software stack will grow? We'll have reuse of different software built on another piece of software, built on another piece of software. And these dependencies can cause vulnerabilities and increase your risk. We need to look at other funding models. Brad's going to discuss some of this in the next talk. So I'm just going to hop over that one. So I've talked about a number of issues to do with sustainable cyber infrastructure that can be addressed both within OCI and across NSF. We can put more requirements in solicitations. What should they be? What's fair? What will help us get to the point where we know that a piece of software coming out of a program is sustainable and reusable? How do we have mechanisms to see if this software actually works? More than just a build and test. Within NSF, we need to change the culture there as well. We need to look at having longer term programs. We need to look at industrial participation, working with other funding agencies, having reuse across the directorates. More money is not the answer. Spending that money wisely is the answer. If we have a longer term program, we're not talking about additional funds. We're talking about taking the money we have and changing how it's used. We need to substantially change the culture that we're dealing with here in order to have sustainable cyber infrastructure. I've mentioned a number of these questions. Hopefully some of them will get addressed today. Some of these have turned into breakouts. How can funding agencies encourage PIs to produce sustainable reusable software? How can educators assist in the production of sustainable reusable software? What approaches have worked well? What approaches have failed miserably? We need to address the failures as well. How do we ensure software in one discipline can be applied to another, or should we? In some cases, it's not going to work. What's the right ratio of software to hardware funding? This is a conversation I started up with Ian Foster about 6 weeks ago. I was at a large meeting, and the question came up of what should these percentages be? Even gathering information about what the percentages are now is extremely challenging. Nobody knows the right answer to that. I'd love to have a suggestion for a large project coming out that says, you know, you need to spend about 1/3 of your budget on software. You need to spend 10% of your budget on software. I don't know what that number is. How should NSF decide what software to support beyond just merit criteria? How do we have a functional architecture across cyber infrastructure? How do we build the rewards in? How do we provide metrics? I think these are all questions that I'm looking forward to hearing answers to and discussing today. If you'd like some additional information, this is me at NSF. No one can spell my last name, so I've actually gotten them to alias my initials, which is great. I'm happy to talk to you about the Campus Bridging Task Force. Craig Stewart is the advisory committee member who's overseeing that with me. The Software Task Force, as I said, Abani Patra is overseeing. David Keys is the advisory committee member, working with him on that. And of course, these ideas aren't just mine. They've come out of a lot of conversations with a lot of people in a lot of places. So with that, I'll conclude and ask if anyone has any questions that they'd like to start it now. Thank you. Yes.
My name is Brian Smith. I've been involved, as some of you may know, in the production of software for 40 years. One of the hardest things to convince people of, which is right in here in spades, is you have to design sustainability in right at the design time. You cannot do it afterwards. If you try to do it afterwards, you fail. Just like testing, just like software design, you've got to put all that stuff up front and not at the end. At the end, it's too late. You've lost the game by that time.
Yeah.
And that's the whole issue there. It's got to get into the education system. It's got to get into the issue of how people design stuff.
Right. So I was asked to repeat questions. So I think that was Brian Smith, and he's reiterating sustainability has to be planned for from the start, not just in the design of the software, but in the education. And I think this is going to be one of the breakouts is actually going to be looking at some of those. Gerhard?
So I guess I want to comment that I see a distinction between writing software for different audiences for different purposes. I mean, infrastructure is meant to be for general use, like a street, like a telephone line, like a building. If you want to have a building built by graduate students, fine, you please live in it. But it needs to be software that actually, in that infrastructure sense, that is actually operational and fully functional. lot of software that's being written for a paper. Yeah, I've demonstrated that once, and I handed it off. I'm going to write my next paper. And that is not infrastructure. That is an experiment into science. And we need to clearly distinguish that. And then there's science guys like me that want to write science software that might write a paper once, or they, it's an infrastructure.
What do you want me to do about people?
So the point.
Stephen, you had your hand up next.
Right, so I think one of the key issues here is actually the ability to make these decisions, because one of the things that industry does very well is to decide what there is no benefit in putting functionality into software and actually making the hard decisions to produce software that is of a high quality. So not only is there needs to be a partnership, as you pointed out in the decision-making process, but I would actually even suggest that this community, in terms of academics, researchers, is actually the wrong community to actually deliver production quality code, because the mindset is too far away from where most of our minds are, and also gives us too much of a conflict of interest in actually making sure that anything gets delivered. The benefit of putting something cool in is always too much.
I disagree. We're very close to the topics that we need to know that get solved, and we're in the front end of science. And the stuff we need, you can't buy. But if you put in a professional team who can build it, if it's an open map, you can't buy it.
Well, I would disagree.
So conversation is going to happen in the breakouts later today. You had a question?
Yeah, or a comment. As it very
Sent me a link. Bonnie suggested I look at some of the NIH sustainability programs, but he didn't give me enough information to follow up on them. So that would be great if you could send me some information on that. There are a number of programs in other funding agencies within DoD, NIH, DOE that are also looking at these issues. So part of what I'm hoping will come out of this discussion today is who's done this before, what can we learn from other approaches? I think that's very important. John?
Well, there's a number of things in your talk that I think were good. I would comment on, but I'm sure they're going to come up in the breakout sessions. But one thing I did want to comment on, and that is you made the comment about writing a bigger check and versus spending the money more wisely. As NSF funds some ongoing development and creation of new software, there is a corresponding growth in the need to support that software. At some point in time, we run into a problem where you're either spending all your money to support the software exists, or you have to deprecate some software. Uh, we don't really have a process for this. And
Right.
I think that is combined with, and I hope that you're sort of spearheading a change in this, but combined with a culture at NSF that it doesn't fund infrastructure. It funds research and science. And so this is at odds with
Yeah.
NSF.
So I was asked to repeat the questions because they're actually webcasting this. So I think capturing your conversation, we need to be concerned about the growth of sustaining all the software that's being supported now. We need to think about software as infrastructure. So I did actually, one of the questions that I think I asked was, how do we choose what software to support? One of the open questions for me, wearing my campus bridging task force hat, is I would love to recommend to a campus, here's a basic software stack that if you deploy it, it will work with these other state, regional, national infrastructure. How do we pick that? How do we make those decisions? People hold up the decision by NSF to support TCP/IP as a fundamental change in how we approach networking as infrastructure. By making that choice at that time, we shifted how things were. There were projects that didn't get funded because of that. Every time you pick a winner, you pick a loser as well. So how do we address that going forward? That's a very important question. I don't know the answer to it. We also do need to talk about end of life. How do we deal with ramping things down? And Marone's going to tell me where I've gone wrong.
At the
Mm-hmm.
same time, this is the kind of thing that this is millions of dollars of experience that people walk away from. And we need to have a way to describe those that succeeded and unfortunately those who failed. I was recently on a National Academy study, and there was a scientist that came and gave a list of millions of dollars of software efforts that all nothing to deliver. But going to the challenge of how do you pick, I think it has to be picked based on a systematic quality assurance approach within the community, whether it's Gerhard, quality, or Stevens, or whatever. And unless there is an investment, and the investment is not like creating new money, but taking away some of the development funds and putting it into systematic quality assurance. And understanding, Provenance has to pick something. You have to know whether it's good or bad, and I don't think that you know it with this one.
Yeah.
I think continuing what Miron was saying, I think the review criteria for sustaining an existing software or infrastructure has to be very clear. So of course it has to be, it is sustainable means it has to exist and it is in production already. And then we have to have a clear criteria, determine whether it needs to needs to be sustained or what are the alternatives. And the review criteria should be very clear to understand.
So it'd be great if one of the breakouts could discuss some of those criteria, because we don't have enough within NSF to make these decisions. What we'd like to have is buy-in from the community. These are the right metrics to judge this type of project. This isn't us dictating to you what we're doing. This is us trying to understand how do we encourage the development along sustained cyber infrastructure. Vaughn?
I just wanted to second a number of previous comments. I think part of what we're getting at here is developing a software life cycle. And I think every professional and commercial company understands this. This includes, early prototypes so that we can decide what's worthy going forward, and then we move them into a real sustainability phase. And I think SDCI, the way it's called, had this notion of a prototype versus that. I think enhancing on that. Yeah. Great quote about prototypes. It's not a question of whether or not you can produce it, it's who you're going to inflict it on.
Yes. Please.
I also agree that we need to be considering what the commercial sector is doing here. But in deference to my colleague from the Evil Empire in the back row, I don't think the commercial sector has this figured out either. And I have participated in that enterprise before, and they're struggling as well with the appropriate lifecycle management techniques, end-of-life processes, and how to integrate legacy code with new code. So this hasn't been solved in any great degree, but we have an opportunity here to do it differently because of the community nature of the approach that we've taken. If it left purely to the private sector, TCP/IP would not have emerged, right?
Mm-hmm.
The picking winners and losers is in fact something that we have to be more circumspect in recognizing we are doing and we must do, because you cannot allow 1,000 flowers to bloom forever, because then you end up with tens of millions, all of which die.
Thank you. Deb.
So just to throw a monkey wrench in that hasn't been mentioned. The other thing we've got to keep in mind is that, here we're talking about the science community as the group we're supporting. And they're trying to do leading edge things at scales that haven't been done, things like that. We also have to factor into this fact that as a core fundamental piece of this, we're not building commercial software typically. We are building something that has never been done before, that is something that is the first time we're trying to do. And so it's also going to be this balance between keeping up with being ahead of that curve and being able to do new things, yet also providing something sustainable. And I think there in the science community, that's going to be one of the really core challenges here.
Okay. Stephen, you have a response to that?
Right, so this comes up to the first part question, what is the software cyber infrastructure we wish to sustain? And I would argue that this, you want to start off at the lowest level and get yourself a solid base, so that when you come along and start hammering this lowest level 250,000 times a day in the case of WOCG use of MyProxy,
And I think Marone had a comment on that.
I'm all for moving forward, but unless those who give me the next greatest data tell me how to move from where I am. So I'm running today an infrastructure scattered throughout the world, and you're coming to me with yet another new idea. If you're not telling me how to reliably move my infrastructure from where I am to where I need to be, it's useless. And I think that most of those who come up with these new brilliant ideas have no continue to devote any thought to what is the transition. So yes, we need development, but it has to be done in a way, as long as if they want it to be used in infrastructure, if they want to write a paper and get tenure, that's all fine.
Go ahead.
Yeah, I want to draw an analogy between the exciting, the new, and the entertaining thing, which is a Formula One race, and the building an infrastructure where a normal minivan with a family rides along on vacation or on a business day to get their work done, or to get to their work. The new exciting stuff is very cool, that's very fine, and there should be funding for it. But the U.S. is spending billions and billions of dollars on the streets, and nobody even really questions that. But because we have become reliant on it, and because we've become reliant on it, everybody uses it on a day-to-day basis, and software has not reached that state. We are always, apparently, maybe, interested in the Formula One race. But we have to scale back and say, I want to place a phone call, and I don't want to call an operator and ask for a line tomorrow so I can call Germany. I want to place a call now.
Yeah. So I think that
a different mindset.
that
I agree with you when you have a university environment where people are interested in the Formula One race, but there's other people at universities that are interested in the minivans and allowing people to do science in minivans. And NanoHub serves over 400,000 simulations annually, reliably, to over 7,000 users. I mean, to me, that's infrastructure that works. So you can do it in a university if you have that mindset.
okay, Neil was first.
Okay, I've been thrown another monkey wrench though, because I agree with all the conversations we've had. Around here, which the application lies with roads. So it's part of the sustainability. I don't think we can just look at one individual piece of it, whether it's just what we consider the low-level infrastructure, or whether we consider it the way that the applications are pushed out to different users and so on. I think you have to consider the whole ecosystem, because otherwise you're only sustaining one part, and that's not a sustainable system.
Okay, so I think a last comment from Stephen, and then we're going to have to wrap it up for this session.
Go back to the question we were talking.
So I think these are good topics for the breakout sessions this afternoon. The software life cycle, how do we have the rewards, what are the metrics? Thank you very much.
So I think I should go on record in saying I'm not opposed to changes in the tenure system. I'm just not sure our working paper, our white paper, will get that done. So we'll continue with the next talk, and the title is an industry.